Welcome back. This time we're going to do a little concept video where I'm going to introduce to you basically three concepts, but they're all related. It's the concept of association between classes. Remember that classes in object-oriented design don't exist kind of on their own. Yes, we have looked at classes and subclasses, which means you can have classes that are sort of that extend other classes, as we have seen. But then when you work in an application, you're going to have all of these classes, they sort of work together to make your application work. So we're going to see today in our traffic light running example how the different classes that we have work together to make this application running. So let me share my screen so you can kind of see what we're talking about. All right, so an association is basically a collection of the different types of classes that work together and collaborate with one another. And we have sort of seen this in our previous videos. So for example, if I just go back and show you the light example that we worked on, yes, we created a traffic light class and we created a subclass of the traffic light class. So those two were the most important, and these are the ones that we basically worked on. However, there were these other classes that were also involved. We talked about the light class. Each of the lights in the traffic light was actually an instance, an object of the light class type. You can see that in some instances, I'm actually providing the type of the attribute. So red, yellow, green, I'm showing colon light. That means red is of type light, which is basically this class. Whereas in these guys, I'm not actually showing you the class type. Now in a proper object-oriented diagram, you should try to identify the type of all your attributes as much as possible. But as you know, in Python, it's a sort of a loosely typed language. So you could actually change types as you go along in the program. So it's not all that important to ensure all the types are there. So as I was saying, this traffic light actually was using these lights, and similarly, our pixel traffic light was using a pixel. So essentially, it had an association with the pixel class. So today, we're basically going to learn more into these relationships between these different classes. So a relationship between two objects, and it could be more than two, but typically you would have a relationship between two objects in an application, and that's what an association is. So when you create an association, you essentially draw a line between the two classes that are associated. So in this case, I have a faculty class and a course class, and we're drawing a line saying a faculty teaches a course, right? Course has their own attribute, faculty has its own attribute and operations. Now, when you connect them, you sort of have to say how many times do they interact, right? So for example, a faculty member may not teach a class at a certain semester, but if they do teach, they might be teaching multiple classes. So on the side towards close, so when you look from faculty towards the course side, you say 0 dot dot star. That basically says faculty may not teach any course, but can teach multiple course. Now, if you look from the course's perspective and looking towards faculty, given a course, there should be at least one faculty member teaching it, but sometimes a course could be taught by multiple faculty members. So you can say 1 dot dot star. So that is called multiplicity. And multiplicity could be shown with these ranges. For example, 0 dot dot star, that means it's an optional, may not have one, but could have multiple. And if it is required, So course is required to have a faculty, then you would have one dot dot star. And if both the lower limit and the upper limit happen to be the same, that is, a course can be taught by exactly one faculty member, you don't even have to show the range. You can just say one, and that would give you exactly one faculty member. So with these multiplicity constraints, we should be able to answer these questions. Does every faculty member have to teach exactly one course? And if the answer is no, that first number is going to be a 0. So that's what an association multiplicity is. And so when we go back to this traffic light example, it basically says a traffic light controls 3 lights, right? Exactly 3 lights. So there is no range, it's an exact. And then a light is installed at a specific traffic light. So you can't have one light installed in multiple different traffic light. Whereas in this example, a pixel traffic light controls a single pixel, and a single pixel is at a traffic light. So there's a one-to-one correspondence between the two. Let's go a little further just to give you a bit more example. We'll come back to the traffic light again in a more detailed manner. So again, we learned about multiplicity. Association should have a name, and you should give some kind of a name, even if that name does not, exactly describe what is happening. You should still try to give a name to decide, which direction this relationship is going. Sometimes relationships are bidirectional. And if you have a specific direction, you can actually show a directional arrow in the UML class diagram. And we are going to do a video where we draw these diagrams, and I'm going to show you how to draw these diagrams with various tools. So this arrow represents which direction this association goes. This essentially says, in this case, a staff member liaises with a client. So it's basically the relationship goes from this side to that side, which really essentially means that you are going to have an array in the staff member object, which is basically a list of their client, right? So typically directionality tells you which side will have the actual data for the other classes. Remember, whenever you have an association, you should have an instance or multiple instances in some cases of the object that you are associating with. That's how in object-oriented applications you keep track of associations. For any of you who are familiar with databases, in a database, when you have association or relationships between two tables, you put what is known as a foreign key. So obviously here, in an object-oriented design, there's no concept of a foreign key. You can actually put the relationship, you can put data for other classes in one class, and you can have that both ways. So I could technically have a list of staff member clients for the staff member class, and in the client object, I could have the name of the reference to the staff member who actually manages that client. A couple more examples. Again, these are just saying a campaign could have many advertisements, but may not have any. That's basically why that 0 is. But an advertisement is only part of one single campaign. And the direction is going this way, which means your adverts are going to be stored in the campaign class. Same with like a card game, you could have a hand that can contain at least one card, could have up to 7 cards, but no more than that. So a hand object will have a list of all the cards that it has. Whereas a card may be in a hand, or it may be just sitting on whatever free deck that is, and it does not belong to a hand. Let's now talk a little bit about a little more advanced from association. So, and this is where things become important in object-oriented design, because now we are actually seeing who controls, who manages these associations. So there are two different things we're going to be talking about here. Aggregation is essentially a whole part or has a relationship. So for example, this is like a graphics system, let's say. You could have a sheet which has a bunch of lines drawn into it. So this sheet is composed of these lines and the boxes that are created in there, right? Um, Now, if you look at a line has a set of line segments, okay? And these line segments are part of the line. So here is how this works, that if you have a line that has composition with a line segment, what you would do is if you were to remove that line, that is going to take away all of the line segments that are contained in that line. So that's what composition is. So the empty diamonds, they are aggregation. This just represents a whole part relationship. And the filled diamonds represent a composition that says that they are an integral part of it, which means if the whole is removed, the parts go away with it. And you will see a much more understandable example in right now. Okay, so this is our example that we have been doing so far now. This is the one that I have sort of completed the entire picture. We haven't really looked at all of these different things, but now we will look at them properly. Now, I have actually created another class here just to make a point. If you see that we have incorporated basically all the things we have looked at so far. We have looked at classes. So all these boxes are our classes. So I have 5 classes plus this 6th one that I just added in here to make a point. This one actually doesn't appear in the application that we designed in the previous video. But first, let's take a look at just a regular relationship. This is why I added this class, this intersection class. So a traffic light is installed at an intersection, right? An intersection may not have any traffic lights, or it could have multiple traffic lights. Right? You have probably seen intersections that have 6, 8. I mean, each side may have 3 or 4 traffic lights. They all work together and so forth. So you could have a whole bunch of traffic lights installed at an intersection. And a traffic light may not be installed in an intersection, maybe just a spare that is sitting at some DMV office. Or if it's installed, you would know where it's installed at. So if we were to do any maintenance on it, so we would know exactly which traffic lights are installed in there. But this is sort of an association, which basically means that, yeah, we could install a traffic light at an intersection, but it's sort of a loose intersection. It's a loose association. Let's think of it that way. I mean, some of you may even say that, okay, it could still be an aggregation because traffic light is part of an intersection. Yes, I mean, in a way, this is sort of a loosely defined, but we're talking about two objects that are kind of unrelated, but they're only associated because they have something that brings them together. Okay, so it's not necessarily that they are whole part relationship. But when you look at a traffic light, the 3 lights that are in the traffic light are components of that traffic light. So it is definitely a whole part relationship, right? So when you look at a traffic light, there are 3 lights in it, and the traffic light controls those 3 lights. But this is an aggregation because um, we can remove a light. So let's say one of the lights blew out. We can remove that light and replace it with a replacement light. Or if a traffic light has malfunction, we could, decommission that traffic light. We can remove the lights that are in there and we can repurpose it in another traffic light. So that's why this is a composition. Sorry, this is an aggregation. So traffic light does have lights as its parts, but it is possible to remove the traffic light and still have the light in action. Let's take a look at a composition. When we did this example where we had this guy, the RGB LED, and in fact, if we run this thing, you're going to see this running. So this RGB LED that has a red, blue, and green light inside, right? And those three are an integral part of this RGB LED. You can't remove one of them because they're all integral part of it. So that's why this is a composition, which means you can't remove one of these dimmable lights from the pixel. They are really manufactured into the pixel itself. You can control them separately, but they cannot be removed. And if the pixel dies, so let's say the blue component of the pixel decides to burn out, well, you have to replace the entire pixel, which means all the lights go away. Okay, so you can't just replace the blue component of the pixel and not replace the other ones. So that's what is a true composition, and that's the difference between aggregation, which is an empty diamond, and a composition, which is a filled-in diamond. Same thing with a pixel traffic light. We are saying that this is an aggregation of the pixel, and each pixel is a composition of the dim lights. So that's in a nutshell what a aggregation, composition, and association are. And this is what a class diagram looks like. This intersection class did not exist in our application that we built. In fact, in the previous video, we actually built another class called light strip traffic light, which associated with a light strip class, which was a subclass of light class. So you can take that as a little task to yourself to complete that diagram if you want. So that's basically what we learned in the last couple of videos. We looked at all of the different advantages of using object-oriented design, and we learned a lot of concepts like objects, attributes, methods. We learned classes and subclasses, which is generalization, and we learned aggregation, composition, which are types of associations. So that was helpful. Sorry that no demo today, but we will have another demo coming up shortly in the next video. See you next time.